Hello everyone, and welcome to a day with a lot of graphing. And by the end of the day we should be able to graph the 6 trigonometric functions with period changes, horizontal shifts, amplitude changes, kind of the full gambit of transformations. Aside from, I would say, I probably won't do any that include a horizontal shift and a period change, just because that gets pretty messy. So we also don't entirely know just yet how we need to graph secant of x and cosecant of x. So those are two of our new trig functions. And I will say that the graphs of those are very closely related to the graphs of cosine and sine, respectively. And so in order to graph them, really we need to first be able to graph 2 sine 2x. So in order to graph, and maybe I'll just kind of write that, in order to graph, for this particular one, this would be 2 cosecant 2x, right? Because that's the reciprocal of 2 sine of 2x. In terms of its corresponding trig function, sine goes with cosecant. So in order to graph this, we need to first graph this. And we're going to get to see why in just kind of a little bit here, but let's first just try to graph that 2 times the sine of 2x. You'll also notice that I have this video broken out into 3 different parts, and that's mainly just to prevent myself or the application from breaking and me needing to start from scratch the entire time. Alright, so 2 times the sine of 2x. I did start with my basic graph, so this is just sine of x on my graph. Sine of x starts at 0, goes up to 1, back to 0, -1, and it's going to make that full rotation in 2 pi, so that helps me kind of come up with all of those points. I've also graphed more than just one period here, so that we can kind of get a good sense for everything that's happening. Alright, so now if I need to graph 2 times the sine of 2x, that means that everything is happening a little bit quicker, or all the x values are going to be half of what they were. And that's the first adjustment that I'm going to need to make. So previously, and maybe I'll do the amplitude change just kind of at that same point in time. So I need sine to make a full rotation within pi, because my period is now just pi, and the amplitude of that graph is now twice as high as what it was. So this is now going to be up here, down here, this point's going to be here. So this is now going to be one rotation of that sine graph is going to be looking like this. Twice as high as what it previously was, and also twice as fast. So I'm just going to try to complete a few more periods here, just so that we have an idea for exactly how this graph is behaving. And let's get a negative period or 2 in here as well. Okay, so now we have 2 completed, we have our graph of 2 sine of 2x on here, and we need to relate this to 2 times the cosecant of 2x. And this might be worth taking a look at in Desmos on this kind of first instance here, because it's pretty interesting what's going to happen. Since this is the reciprocal, one thing that I can make note of is, and I'll try to go with something a little bit darker, is that when this graph is at 0, the cosecant graph is actually going to be at infinity, okay? Or it's going to have a vertical asymptote. So this graph, the graph of 2 cosecant of 2x, at first we know that it's going to have asymptotes anywhere that my initial graph has a x-intercept. So I'm just going to be kind of drawing in those asymptotes at this point in time. So anywhere my purple graph is 0, my other graph is going to have this vertical asymptote, which is going to be a line that our graph can't cross, and it also means basically that our cosecant graph is going to trend towards infinity. Then what we're going to notice is that the cosecant graph is really kind of like the best buddy of this 2 sine of 2x graph. So where it's positive, it's still going to be positive. So where 2 sine 2x is positive, 2 cosecant of 2x is going to be positive. And then wherever this 2 sine of 2x has a maximum, we're actually going to get like a relative minimum for 2 cosecant of 2x. Okay, so I'm just going to draw a few of these kind of portions of this graph, and it does look funky, but that's going to be fine. So this graph is going to swoop down, touch this, and then go right back up to my vertical asymptote, or head to infinity. On this next portion, we kind of switch sides here. This is going to come up, grab that guy, and come back down. And then it's just going to repeat this over and over again as it goes. So the reason why we need to draw 2 sine of 2x first is to figure out exactly how high or how low I should go in order to get these. So once I know the max and the mins, it also helps with coming up with these asymptotes, but we end up with this. All right, I'm going to see if on my video if I can kind of switch over to Desmos without this whole thing breaking. Okay, so 2 sine of 2x we're going to go and take a look at here. So 2 sine of 2x. So we end up with this graph. And then again, the corresponding graph that we wanted is 2 cosecant of 2x. So we can see how they're kind of attached. And you haven't looked at a lot of graph with vertical asymptotes, so that's probably still going to be something that we need to talk about in class. But just know that, we draw that vertical dotted line, and it's a line that cosecant can actually never cross. It kind of jumps from one side to the other of those vertical lines. But then, obviously, this is leading to that nice relationship between the two graphs. And if we were just tasked with graphing this, that's kind of our answer to the graph of, what does 2 secant of 2x look like? It looks like this, which is nutty, but I can't really do that without first having graphed this, okay? So let's see if I can do this other one in a relatively short time frame and see what that graph looks like as well. All right, so here we've got cosine. So this is going to be used in order to graph 2 secant 1/2 x, because secant and cosine are reciprocals of one another. So that's how this is going to help us out. Notice, since this is cosine, this periodic function actually starts at 1, and it completes a rotation in 2 pi. So that kind of helps us. This is just our basic graph of cosine of x that you can see right now. And then I'm going to kind of get started on 2 cosine 1/2 x. So first thing I notice is the amplitude is going to be 2 versus 1. So all these y's are going to be stretched out. And then a half, being our b value, means that our period is now going to be 4 pi. So this graph is going to take twice as long to finish. So it's going to go from 2, and then it takes until all the way over here to get back to that value. And then I've got these kind of intermediate values. Let's see, it'd be pi, 3 pi. So we've got this guy coming down, coming, oh, I missed it completely. Let's redo that line. Okay, so this one definitely takes a little bit longer to complete that full rotation. And there's different like strategies for coming up with this. I'm coming up with just the maximum and the minimum, and then I know that directly in between there it's going to end up being 0. And I don't need to like have a table to do that. I can just kind of come up with it from there. And then this is going to behave no differently from our previous graph. Okay, so we're going to have vertical asymptotes wherever cosine is at 0. So I'm going to plug that in. So here the x-intercept of my purple graph was at 0, so these are going to be vertical asymptotes for secant of x. Plugging that one in. And then in order to finish drawing secant, I'm just going to draw basically the partnering sides of this, right? So this is going to come down, come up. And make sure that that doesn't cross that vertical asymptote, okay? It kind of just trends infinitely towards it. So this is going to go like this. So do these graphs look weird? Absolutely. And it's important to kind of note that our final, like if we were being tasked with just graphing this, then all we would really expect to see is kind of that blue line in finality. And that's what Desmos would spit out. But obviously we need to graph 2 cosine half x if we're doing this by hand in order to get to an accurate value for that. All right, that's going to be page 1, and I'll do some more videos. Thanks.